All right, so as I said to you guys earlier, this week it's kind of split into like two mini units. 8.1 and 8.2 are their own thing. 8.3 and 8.4 are their own thing. So we're doing 8.3 and 8.4 first. So that'll finish up the harder stuff. And then Wednesday and Thursday, we're going to do the easier stuff, which is 8.1 and 8.2. And it's totally separate from what we're doing in this first part of the week. So the two things we're going to look at in this section is how can you raise a complex number to a power, and how can you take a root. So first, I want to just look at an example of raising a complex number to a very simple power, just the second power. Right? So let's take, and let's do some actual numbers. 3 plus 2i. And what I'm going to do here is square it. If I wanted to write, what would I put right here if somebody didn't understand what it meant to square something? Like how would I explain what to write down after the equal sign? Yep.
Multiply it by itself. 3 plus 2i.
Yeah, just write 3 plus 2i times 3 plus 2i. And now we have to FOIL. Okay. So when I FOIL this out, Brianna, what's 3 times 3? 9. And Emily, 3 times 2 plus I? I'm sorry, 3 times 2i, which is 6i. And 3 times 2i again. 6i. And now 6i plus 6i is how much? 12i. And then we have 2i times 2i. Caleb, what's 2i times 2i? 4i squared. And 4i squared is really what number? That's really negative 4. What's 9 minus 4? 5 plus 12i. So that's the answer when you raise that to the second power. It didn't take that long. Maybe it took us like a minute. Probably do it faster if you just did it yourself. But now, if I wanted to do something like z to the 5th, that means now you're going to be writing 3 plus 2i, 3 plus 2i, 3 plus 2i, 3 plus 2i, 3 plus 2i. Now you have to FOIL all 5 of those out. It's still something that you could do maybe in like 5 or so minutes. But then if I said z to the 200th power, well now forget it. It's too complicated. So the point is, it can get very, very challenging very quickly to raise a complex number to a power. There's not hard steps. There's a lot of steps, and there's a lot of things that you could mess up. You could forget to change I squared to -1. You could combine like terms wrong. You could just multiply wrong. You could do 3 times 3 and just write 6. You meant 9. So a lot of things that could go wrong. So what we're going to look at is what's called DeMoivre's theorem. Okay. DeMoivre's theorem gives us a very simple way to raise a complex number to any power that you want. So if you wanted me to do z to the 3rd, or you wanted me to do z to the 300th, I could do either problem just as fast. The exponent doesn't make a difference in how long it's going to take to do the problem. But what DeMoivre's theorem depends on is trig form. You have to write your number in trig form. You can't write it like this. That doesn't work. If you're going to write it that way, then you got to do all the foiling. It's going to take forever. So let's suppose that we had a number in trig form, and we want to raise it to the nth power. In an actual problem, you would know your radius, you would know your angle. They would give that to you. Or you would find it, like you did in the homework. So there's only 2 things that you have to do to raise that number to the nth power. First thing you do is raise the radius to the power, r to the n. Now you can just type in on a calculator. Just Might be a big number. Depends how big r is, depends how big n is. All right? But raise r to the nth power and multiply the angle by the power. So raise r to the nth power and multiply the angle by the power. And that's called DeMoivre's theorem. So we'll try an example of that and see what happens. Okay. So this problem, they're only asking you to cube something. Whether or not DeMoivre's theorem is really going to save you a lot of time if you're only cubing something, it might be faster to just write out 1 plus 3i, 3 sets of parentheses, foil the first two, get that answer, and then foil it again. But when this exponent starts to get up like a 5 or higher, it's definitely saving you a lot of time. Okay. So what's the first thing that I need to do with this number if I want to cube it using DeMoivre's theorem? Yeah.
Find the radius and the angle.
Right. I got to get it in trig form, which means find the radius, find the angle. Okay. Eric, what's the real part of that number? 1. And Jacob, what's the imaginary part?
The 3 squared.
The what?
The 3 squared.
3 squared?
3 cubed. Sorry. Or square root of 3.
Square root of 3. Yep. So 1 is the real, square root of 3 is the imaginary. Positive, positive, you're somewhere right around there. That line segment that I just drew, that's your R. Make a triangle out of it. 1, square root of 3. So let's find our radius. Nikira, when I do Pythagorean theorem on that, what's my radius going to come out to? So if you were going to set up Pythagorean theorem here, how would you plug all the numbers into it?
1 squared.
1 squared plus what?
The squared.
Yep. Equals c squared. Yep. Or you can pick any letter that you want. And now, what do you get when you do out what's on the left? So what did you get for this one first? 1 to the second power, 1 times 1, which is 1. And then the square root of 3 squared? Yep, the square root of 9, which is 3. So now we have 1 plus 3 equals c squared. So that gives us 4 equals c squared. Chris, which means c equals what? 2. So radius is 2. And my angle, Kaya, how do I get my angle if I am in quadrant 1? Do you remember the trig function? Zach? Yep. Of what over what?
Y over X.
Y over X. Do you add 180?
No.
No, not in this quadrant. 1 and 4, you don't have to add the 180. So inverse tan y over x, so it's really just the inverse tangent of the square root of 3. Now, I'm going to do it in degrees. If they ask for a problem in radians, you can always change your angle at the end of the problem to radians. Alright, so second inverse tangent, square root of 3, gives you an angle of 60 degrees. So, got my angle, got my radius. Let's write the answer, and then we can cube it, which is going to be the easy part. Be very quick. So Sam, how would I write down the trig form of 1 plus root 3i?
Will be like 2
Yep.
parentheses.
Yep, good.
Cosine.
60.
And then the plus I sine.
So whatever you use for your angle here, you're going to use the
Or
same
no,
thing there.
okay, so 60 there.
60. And that's how you write that number in trig form. Now, Jared, what power are we raising that to?
3.
3. So here's DeMoivre's theorem. You're going to take that, I just ran out of space, and you're going to cube it. So Brianna, what do I do to get my new radius? Yep, 2 to the third, which is going to be how much? 8 cosine plus I sine. So now you just have to figure out your angle. So you raise the radius to the power, and what do you do with the angle in the power? Multiply, which gives me how much? 180 plus I sine 180. And that is what you get if you cube 1 plus root 3i in trig form. So that is the answer in trig form. Now, if you want it in standard form, do that out. Take 8 times cosine 180, that's the real part. Take 8 times sine 180, that's the imaginary part. So let's see what 8 times cosine 180 comes out to. -8. So -8 plus, now do 8 times sine 180, and it'll have an I next to it. 8 sine 180, 0. What's 0 times I? 0. This is gone. So all you get is -8. That's standard form. And that's how you do it. So on the test, you might have some problems where I just say you can stop in trig form, or I'll say take the trig form and do it out, and that changes it to standard form. You're not wrong if you leave plus 0i. You just don't need the 0i. Okay. Any question on that? So I want to think about this for 1 second. You took what I just underlined in red and you cubed it and you got -8. How could you take -8 and go back to what you started with? So you took what was in red, you cubed it, and you got that. How could you take that and reverse it and go back? Cube root, yes. So if you take the cube root of -8, that would be one of the answers. We're going to learn that when you're taking a root, there's as many answers as the root you're taking. Cube root means 3. 5th root, 5. 10th root, 10. So we usually don't do anything above 5. But we're not going to do that yet, but I'm just trying to point out where we're going to be going. Right? We can reverse that and cube root it and get that. All right, let's try this one. Now, is this one that you could reasonably do out in, say, I don't know, 30 seconds in standard form. No. You're talking about writing 8 sets of parentheses that are all fractions with square roots and foiling everything. You're not going to probably do that in under 5 minutes. But if we change it to trig form, once we do that, we can do the problem in 30 seconds. Right, so let's start with our radius. So Caleb, to find my radius, what formula do I always use? Because it's like we have two sides of a triangle. Pythagorean theorem. Here are the two sides of your triangle. Square each one of them, add them up, and take the square root. I think we did this one actually, or very similar in the homework. What do you get when you square negative root 2 over 2? So you're going to get 2 in the top, you're going to get 4 in the bottom. That's 1/2. What do you get when you square positive root 2 over 2? One half again. When we add those up, what do we get? And then take the square root. 1. So your radius here is 1. Okay, now your angle. Angle is going to be, well, let's think about the quadrant we're in. Brianna, what quadrant is this in? Because we have a negative and a positive. Yep. It's going to be a quadrant 2. And the formula for theta in quadrant 2 is, does anyone remember what's the formula for that? Here?
Inverse tangent plus 180, or inverse tangent of y over x.
And what's y over x in this case? If you divide them.
1.
-1. Inverse tangent. What's the inverse tangent of positive 1? We did that earlier. What does that come out to? 45. So the inverse tangent of -1 is -45. -45 plus 180. Brandon, what does that give me? Yep, 135. There's your angle. There's your radius. So Eric, how would I write this number in trig form?
1 parenthesis cosine 135 plus I sine 135.
Nice. And what power are we going to raise all of this to? Yes, 8th power. Okay, so let's do that out. So Jacob, what do I do with my radius to raise it to the 8? Like, what's my radius going to be?
It'll still be 1.
Right, we're just going to take 1 to the 8th power, which it still stays as 1. And what about my angle? 135 and 8. What do we do with those? Yeah. Multiply them. So we get 1080. Now, you're not going to see an answer on a test with an angle that big. So what do you do to make it smaller? What did you say again? Something with 360. But, yeah. Subtract. So subtract 360 as many times as you can. In fact, you could do it 2 more times. And what would you get?
360.
And then you can do it again. 0. So 1080 is exactly the same as 0. Kind of a boring number in trig form. The angles are 0 and radius is 1. But that's what it is. Okay, so we raise the radius to the power, and we multiply the angle by the power. And a lot of times, when you multiply your angle by the power, it gets pretty big. So you need to subtract 360 to make it smaller. And if they wanted this in standard form, you could do this out. 1 times cosine 0 plus 1 times sine 0 and put an I. Well, the cosine of 0 is 1. What's 1 times 1? 1. The sine of 0 is 0. 0 times anything is what? 0. So if you simplify that in standard form, you're going to get 1. If you do it in the top way, that's trig form, that answer is also correct. So when you raise this number to the 8th power, you get 1. How would you undo an 8th power? Yep. Take the 8th root. If you take the 8th root of something, I told you earlier there'd be how many answers? 8. If you take the 8th root of 1, that is one of the 8 answers you get. Negative root 2 over 2 plus root 2 over 2i. Some other answers you'd get that would be easy for you to figure out now, 1, because 1 times 1 8 times is 1, and negative 1. So 1 and negative 1 are the only 2 real answers if you do this problem out. All the other 6 answers are imaginary. And that's one of them right there. As I said, we're not going to be doing a problem as high as 8 when we do a root. Power? Sure, I could give you a power as big as 200. But the roots, we're not going to go above 5. All right, so I already asked you guys this question. We cubed something, and we got our answer, and I asked you how would you reverse it. And somebody said cube root. Okay, so we already talked about that. All right. So we cubed something and got negative 8. If you cube root negative 8, it brings you back to the problem you started with. That 1 plus root 3i, I gave you that. That was example 1. So the question is, how would you figure that out? Like if I said, do this problem, which that's a very doable kind of test problem. How do you get 1 plus root 3i as an answer? What do you do? And that's what we're going to spend the last part of class going on. Okay, so how you take roots. Okay, I'm going to give you all the steps first, and then we'll go through as many problems as we have time to after that. We'll probably do about 3 problems. So, first thing to kind of understand, just let me show you something. Let's say you wanted to find the square root of 16. Okay? And you ask somebody that and they've never seen square roots before. So they don't really understand what that means. But they understand exponents and they understand how to solve equations. So if you wanted to find the square root of 16, that means you're trying to figure this out. If you can tell me what number that you raise to the 2nd power and get 16 as the answer, then you just told me the square root of 16. So solving this equation will tell you the square root of 16. If you wanted to know the cube root of 64, if you can solve that equation and figure out what z is, that will tell you the cube root of 64. So in general, you're trying to solve this equation. If you want to know the square root of 16, do that. If you want to know the cube root of 64, do that. If you want to know the nth root of a, do that. That's the equation that you always are going to set up. Now, remember, a and z can be complex numbers. That's what that means. So it doesn't have to just be the square root of 16. It could be the square root of 2 plus 10i. It could be imaginary or complex. So first thing is, when you write an equation like this, that's standard form. I know it's standard form because there's no cosines and sines in it. Okay? You have to translate that into standard form because everything is much easier to do in standard form. You might even not think this is that easy, but it's a lot easier than not having standard. All right. So, let's write this like this. So when you do an actual problem, they are going to tell you what A is. They may say something like, A is what you're finding the roots of. So they may say, find the roots of 2 plus 3i. Well, your first step, if they tell you that's what A is, you have to find the radius and the angle. That's what you did in last night's homework. All right, so R1 and theta 1 is a radius and an angle for some thing that they give you. Z is what you don't know. That's your variable. Just like here. Z is what I don't know. Z is what I don't know. Z is what you don't know. So literally, every problem, you're going to take exactly what I've written on that line, and you're going to fill it in for Z. Exactly the way it is. You're not going to know R. You're not going to know theta. That's what we're going to solve for. Okay? But you will know R1 and theta 1. You're going to find those yourself right away. So I'm going to make those two substitutions in that equation. Change that to what's on that line. Change that to what's on that line. And now you'd have that. When we do an actual problem, everything on the right-hand side is going to be numbers. There won't be any letters on the right. R1 and theta 1, you'll know. N, you'll know. And the next thing we want to do is use DeMoivre's theorem to simplify all of that. What I should do is write it like this, technically. So when you use DeMoivre's theorem, how do you get your radius? What do you do with your radius and the power that they give you? Yep.
Multiply that, or the radius, you raise it to the power.
You raise the radius to the power. So you'd have r to the n. And what do you do with your angle and your power? Multiply them. Just like that. The right-hand side, in this problem, it's done. The right-hand side never changes after you find R1 and theta 1. Okay, so on the left, in the green box, you have a number in trig form. On the right, in the blue box, you have a number in trig form. What's between the green box and the blue box? Equals. So what that means is what's on the left has to equal what's on the right. Oh, there's two things that have to match. There's a radius on the left, and there's a radius on the right. Set those two things equal to each other. R to the n equals R1. You're going to solve that equation, and that's going to tell you the radius of your answer. So set the radius on the left equal to the radius on the right. Next thing. You have an angle on the left. You have an angle on the right. And there's an equal sign between them. Set those two things equal. So the angle on the left is going to be n times theta, and the angle on the right is theta 1. Now, if you were finding a cube root, how many answers would you have? 3. How about a fourth root? 4. 12th root? 12. Right now, this gives you one answer. And that's fine. When you find a root of a complex number, there's only one answer for r. Where the multiple answers comes in is over here. When we practice solving equations by graphing, what did we have to add onto the end of an answer to represent all solutions? We had to put a plus something. and it represented all solutions, not just one.
Plus period.
Plus the period. So think of sine and cosine. What's the period of sine and cosine?
180.
That would be for tangent.
Pi over 2.
That's 90. No. 2 pi. Period of sine and cosine is 2 pi. So by putting plus 2 pi k, it's like what we did when we graphed and we represented all solutions, not just one solution, but everything. So here, I'm just going to say you're going to get n solutions. How many is n? Depends what n was in the original problem. If it's a cube root, it's 3. 12th root, 12. 5th root, 5. Right, and that's basically how you find roots. So we're going to go through, we'll go through a couple problems, and we just need to practice it. But technically, you could jump right to this final step, as long as you know what n is, which is whatever power they tell you you're taking, or whatever root you're taking. And then R1 is what you're going to solve for right away. It's the radius of the complex number they give you. Theta 1 is the angle of the complex number they give you. So R1 and theta 1 is just like what you did in the homework. And those two things are going to get filled in. R1, theta 1. And n is the root you're taking. So let's just try, without having to go through all these steps each time, let's just try using these two formulas in the black boxes. And what I'll do is I'll highlight the things you need to plug in for. Maybe. Okay, there we go. So I highlight everything you're going to fill in for. You're going to fill in for n. You're going to fill in for R1. Fill in for n again. And you're going to fill in for theta 1. And you can fill in for k. So everything up until that last one, which I'll highlight in a different color, I'll highlight green. All the yellow highlights, you know, you figured out what they are. R1 and theta 1, you figured out right away. N was the root, cube, 4th, 5th root, whatever it was. Now, for k, I'm going to show you what k is. So, I told you guys that when you find roots, you only get a single answer for r. That's why I wrote one answer about it. But you get multiple answers for theta. So, in general, the rule is an nth root has n answers. Okay, we've already said that. So, to find all the different answers, you have to plug in a number for k. What numbers do you plug in? These numbers. You start at 0, and you plug in every number up to n minus 1. So let me show you what I mean. If you were doing a problem that was a cube root, to get the 3 answers, the numbers you would plug in for k are 0, 1, 2. That's how you get the 3 answers. If you were doing a problem about a 4th root, there are 4 answers. The way you get them is you plug in 4 numbers for k. 0, 1, 2, 3. That's your 4 numbers. So that's why it's always 1 less than the root, because you're starting at 0. A 5th root, you'd plug in 5 numbers for k, 1 at a time. The 5 numbers, 0, 1, 2, 3, 4. And that's how you get your 5 answers. All right. So, most important thing there are those 2 black boxes and what's highlighted in that green box. let's try a question. So this problem says to find, we're not going to graph them, find the fourth roots of 1. So I want to solve this problem. If you ever see it written as the word unity, unity means 1. It's just another way that our book says it sometimes. Okay, so find the fourth roots of 1. Now, off to the side, let's just see if we know a couple of them right now, and then when we go through this process, you'll see those answers come up. What can you multiply by itself 4 times and get 1 as the answer? 1. So I'm just going to put that off to the side. So that'll be an answer. And what else? Negative 1. Now, those are the only 2 real answers that you're going to get. So what does that mean the other answers are going to be? Yep. Imaginary. Okay. So let's go back and write down our 2 equations. R to the n equals R1. Okay, we got some stuff we need to fill in there. And how did I write it? N times theta? Yeah, n times theta equals theta 1 plus 2 pi k. N times theta equals theta 1 plus 2 pi k. So now let's make a chart of everything we know. N. What's n in this problem? Yeah, 4. That's the root you're taking. We'll fill it in later. So n is 4. The other thing we need to fill in is R1 and theta 1. R1 and theta 1 is exactly what you did in the homework. Find R, find theta. For what? From that. Write that number in trig form, number 1. Now, you could think of this, if you want, as 1 plus, what's the imaginary part? Yeah.
0i.
Yeah, if that helps you, think of it as 1 plus 0i. So you're changing that number to trig form. Let's start by graphing it. How would you graph 1 plus 0i? Oh, yeah. Yep. Yep, you go to the right one. Now, if you go to the right 1 unit, you don't really need Pythagorean theorem to find the radius. I mean, you could do 1 squared plus 0 squared, add them up and take the square root. But if you just look at the picture, what's the radius? Okay.
Where I squared.
Well, 1 squared plus, what's the imaginary part?
0.
0. So what's 1 squared plus 0 squared? 1. And what's the square root? 1. So it's just 1 unit. So your radius is 1 unit. And what's your angle if you're on the positive x-axis? Yeah. So when it's on an axis, you don't even use a formula. You just have to memorize what it is in that spot. Yep.
Would be 0.
0. 0, 90, 180, 270. You can't use the inverse tangent of y over x because sometimes you end up dividing by 0 with that. But if it's in a quadrant, you could. So your angle is 0. Any questions on how we got n, r1, or theta 1? Okay. Now we fill them into our equations. This is for the radius. The other one is for the angle. So Brandon, what's my equation going to be for my radius when I fill in everything I can? Is this in our chart?
No, so it'll just be r to the 4th.
R to the 4th.
1
So now we've got r to the fourth equals 1. Let's stop and solve that one before we do the angles. Jacob, how do I get rid of this fourth power?
On the root,
Yeah, what kind of root?
root 4.
Yeah, find a fourth root. To get rid of a fourth power, you do a fourth root. Fourth root. Fourth root. That's gone. R equals, what's the fourth root of 1? Yeah. 1. We're not worried about imaginary answers or anything like that here because this is a radius, it's a distance. So it has to be positive and it has to be a real number. So here is your radius that we're going to use to write our answers in a second. Okay. Nikira, how about my second equation? What's that one going to look like when we fill in what we can?
4
Yep, 4 theta
plus 0
equals 0, which in this case you don't even really need it, but we'll keep it there.
plus 2 pi k.
Plus 2 pi k. So the 0, you don't even need it, so I'm just going to go like this. So you're just going to have 2 pi k. And now get theta by itself. Kaya, how would I get theta by itself? Divide both sides by 4. And the answer, plural, answers to this problem, we can reduce that. Answers are going to be of the form pi over 2 times k. Now, how many answers are we looking for? If we were doing a cube root, we'd be looking for 3. 4. Looking for a fourth root. So we're going to plug in what numbers for k to get 4 answers. Yeah. 0, 1, 2, 3. Okay. So now this part gets a little tedious just to write all the answers down. K equals 0, k equals 1, k equals 2, k equals 3. The radius is 1 in every one of these answers. 1, 1, 1, 1. And then what you want to do is cosine theta, I sine theta. Leave some room. Cosine theta, I sine theta. Cosine theta, I sine theta. And cosine theta, I sine theta. Okay. Now, I think what I want to do to make this easier to do, this is correct. Theta equals pi over 2k. If we want to do the answers in radians, let's do them in degrees. What's pi over 2 in degrees? Yeah, 90. Okay. There's nothing wrong with the way we had it. It's going to make it more complicated to try to do things with pi. So let's stick with just degrees. So this would be for radians. This would be for degrees. Okay. Now, let's start by letting k equal 0. What's 90 times 0? 0. That's your first answer. 0 degrees, 0 degrees. Next answer, k equals 1. What's 90 times 1? 90. 90 degrees, 90 degrees. Next answer, k equals 2. What's 90 times 2? 180. 180. 180. Last answer, k equals 3. What's 90 times 3? 270. So 270, 270. And those are the 4 answers in trig form. Now, at the very beginning, I asked you guys, what would be a fourth root of 1? And we wrote this down. 1 and negative 1. Well, 1 and negative 1 is one of those answers, or two of them. If you were to take, let's take this one. Watch what happens if you do 1 times cosine 180. 1 cosine 180. You get negative 1 plus, write it like this, negative 1 plus I times, now let's do 1 times sine 180. Watch what happens there. 0. What's I times 0? I times 0 is what? Anything times 0. 0. What's negative 1 plus 0? Negative 1. This answer right here comes out to negative 1. And that's one of the two answers you guys told me right away. Negative 1. You just told me it in standard form. That's negative 1 in trig form. The other answer you guys told me right away was 1. That top answer is 1. If you did it out. We're not doing it out. I'm just showing you that these two answers are the ones you guys told me right away. The other two answers, k equals 1 and k equals 3, those would be your imaginary answers. So that's basically the idea of how you do a root problem. Let's try, yeah, 2 left. I think, yeah, we'll try, probably have time for both of those. Let's try to find the cube roots of negative 8. All right, so first thing you want to do is just copy down those two equations in black. R to the n equals R to the 1. Or R to the n equals R to the 1. And n theta equals theta 1 plus 2 pi k. Yeah, theta 1 plus 2 pi k. And now we'll make a little chart off to the side for n, r1, and theta 1. What's n in this problem? What was, so look at the equation there and look at what's above it. N is the, yep.
The root you're going by?
It's the root. It's the nth root. So what root are we doing in this problem?
Oh, cube.
Cubed. 3. So n is 3. Now r1 and theta 1 are going to come from this number. I mean, it's the only number you have in the whole problem. So find the radius and the angle for negative 8. How would you graph negative 8? Yep.
Go left 8 units.
Yeah, so go left 8 units. If you go left 8, what's your radius? Radius has to be a positive number. 8. And what's your angle? 180. So this time, since he said it to me right off the bat in degrees, 2 pi is the same as what in degrees? That's 1 pi. 360. So we're just going to do this whole problem in degrees right from the beginning. Okay. So when we fill in n, we're going to have r cubed equals 8. So what's r in this case? 2. So when you write all your answers, and how many answers are there going to be in this problem? 3 answers. When you write all 3 answers, you're all going to have 2 for the radius. 2, 2, 2. Now they're going to have different angles. Let's fill everything in this formula. 3 theta equals 180 plus 360 k. And now how do you get theta by itself? Yep. Yep, just make sure you do it everywhere. 3 divided by 3 is gone. What's 180 divided by 3? 60. And 360 divided by 3? 120. So there's your formula for your radius. There's your formula for how to find your angle. And what are we going to let k equal? One number at a time. Yeah. 3 specific numbers. This. Yep. 0, 1, 2. That's how you get your 3 answers. Okay. So now we just have to write that out. So we have k equals 0, k equals 1, k equals 2. Radius each time, 2. 2, 2, 2. Cosine, I sine. Cosine, I sine. Cosine, I sine. Okay, so let's start with 0. What's 120 times 0? Plus 60? There's your first angle. 60, 60. What's 120 times 1? Plus 60? 180. There's your second. And last answer, times 2. 120 times 2. Plus 60. 320. And those are the 3 answers if you take the cube root of -8. Now, what's one number that you probably could have figured out in your head before we did this? What times what times what is -8? Yeah. 2 times 2 times 2 is positive. -2 times -2 times -2. So -2 is one of these answers. Which one is it? It's that one right there. If you did that out, the sine of 180 is 0, so that part would cancel. The cosine of 180 is -1. 2 times -1 is -2. These other 2 answers would be imaginary.
How did you get 320 into 2?
320? Was it supposed to just be 300?
Yeah.
Yeah,
I
300.
just wanted to make sure I was doing it.
Yep, sorry. It's 300. 240 plus 60 is 300. I think Chris said that, but maybe I was thinking k equals 2 and I just put a 2 in there or something.
I just wanted to make sure I knew how to do it.
Yep. All right, so the last one, I'm not going to go through all the answers, but I'd like to just get it to the point where we're ready to find them. Okay, and then we'll stop there. Okay, so find the 5th roots of 1 plus I. So, what are the 3 things that we always make a chart for?
The answers in 3
The radius,
and
n,
theta.
and the angle. What's n in this case? 5. So you're finding a 5th root, and now r1 and theta 1 come from right there. Let's graph it. Real part in that number is what? 1. Imaginary part? 1. So what's the radius of the point 1, 1?
1.
No.
Square root.
Square root of what?
2.
2. Yes. 1 squared plus 1 squared, and then take the square root. Okay. What about your angle? If you go over and up the same amount,
40.
it's a 45. If you didn't know that it was a 45, what trig function do you use? Inverse
Tangent.
Inverse tangent. Yep. Okay. So now you've got everything you need to set up your two equations. Can someone tell me what's the first equation that I keep writing down? You don't have to fill anything into it yet, Jerry.
R to the n equal R1.
R to the n equals R to the 1. So it's going to be R to the 5th equals square root of 2. And I would use the calculator to solve that. How do you undo a 5th power? Yep.
Log of 5.
Nope, you don't need a log. So how do you, we talked about how you undo cubing, cube root, undo squaring, square root. Yep. You're going to take a 5th root. So if you're not sure how to do that, you press 5, math, option 5. That's how you set it up so your calculator can now do the 5th root of, and you can type in whatever you want. In this case, square root of 2. So you'll get a decimal. What's your other equation that you set up? Yep.
And theta equals theta 1 plus 2 pi there.
Yeah, I'm just going to do degrees because we did degrees up here. So the 2 pi is only if you're radians, 360 if you're not. Okay. And what's n in this case? 5. And theta 1? 45 plus 360. Okay. And if we continued that, what would be your first step in that box on the right? Yep, you divide everything by 5. 45 divided by 5 is 9. 360 divided by 5 is 72. So now you'd be ready to write your answers. You'd let k equal 0, 1, 2, 3, 4. And that would give you 5 answers. Okay. So we can practice another 1 or 2 root problems tomorrow if we need to, but that's the hardest thing this week. Okay, so the homework in the book on 458, it's 3 through 5, 8 through 12, 26 to 28, and 35.